Hey there, science fans! Have you ever stopped to think that physics is everywhere? It's true. From the way your coffee cools down to the reason why your bike moves forward, physics is the secret sauce behind it all. It's about understanding the fundamental laws that govern our universe. And trust me, it's way cooler than memorizing formulas. Physics helps us explain the world around us. It helps us design things like safer cars and faster roller coasters. So buckle up, because we're about to dive into the fascinating world of dynamics and linear momentum. Get ready for some serious aha moments. Dynamics is like the action movie of physics. It's full of excitement and surprises. It's all about why things move the way they do. From the smallest particles to the largest galaxies, dynamics explains it all. Why does a soccer ball curve when you kick it just right? It's because of forces. These forces act in specific ways to create motion. Forces push or pull on objects, causing them to speed up, slow down, or change direction. This is why a car brakes to a stop or accelerates on the highway. Think of pushing a shopping cart. The harder you push, the faster it goes. That's dynamics in action. The same principles apply to rockets launching into space. Newton's laws of motion are like the rules of the game in dynamics. They provide a framework for understanding how forces and motion interact. They tell us how objects behave when forces act upon them. Pretty cool, right? But wait, there's more. These laws are fundamental to everything from engineering to everyday life. Let's talk about linear momentum. This concept helps us understand collisions and how objects transfer energy and motion to one another. Linear momentum is basically how much oomph an object in motion has. It's a measure of how hard it is to stop that object once it's moving. It depends on two things: how massive the object is and how fast it's moving. The more mass and speed, the more momentum it has. Think about a bowling ball and a tennis ball rolling at the same speed. Even though they're moving at the same speed, they have different momenta. Which one would you rather stop? The bowling ball, right? It's much harder to stop because it has more mass. That's because it has more mass and therefore more momentum. The greater the mass, the greater the momentum. Here's the mind-blowing part: momentum is conserved. This means that in a closed system, the total momentum remains constant. That means it doesn't just disappear, it can be transferred from one object to another, but the total amount stays the same. Imagine two billiard balls colliding. When they hit, the momentum from one ball is transferred to the other. The total momentum before they crash is the same as the total momentum after they bounce off each other. This is a perfect example of momentum conservation. This principle helps us understand everything from car crashes to rocket launches. It's a fundamental concept in physics that explains how objects interact and move. Okay, time for some real-world examples. Momentum is not just a concept confined to textbooks, it's something we encounter in our daily lives. Think about a baseball player hitting a home run. The force and speed of the swing are crucial. The bat's momentum is transferred to the ball, sending it flying through the air. This transfer of energy is what makes the ball soar. The heavier the bat and the faster the swing, the farther the ball travels. Or how about rockets? They are another fascinating example. Rockets burn fuel to create hot gas that blasts out of the engines, generating thrust. This creates momentum in the opposite direction, propelling the rocket upward into the sky. The principles of physics are at work here. The more fuel it burns, the faster it goes. This is why rockets need so much fuel to escape Earth's gravity. Even something as simple as walking involves momentum. Each step you take is a small demonstration of physics in action. As you push off the ground, you're transferring momentum from your foot to your entire body, propelling you forward. This is why you move when you walk. See? Physics is everywhere. It's not just equations on a blackboard. These principles are the foundation of how we understand movement and force. It's the science that explains how our world works. From the smallest steps to the grandest rocket launches, momentum is a key player in the story of our universe.